Hello everyone, today we'll say about process synchronization. See, before I start, I want to say you that please subscribe my channel as I'm putting my full effort in making these videos. In this channel, you'll get all the free video lectures for GATE computer science students. So let's start. Today we'll say about process synchronization and race condition. See, this is given the one program, one small piece of code is given, and here x value is given 10. And here this is given two processes P1 and P2. This is the first case and this is the second case. First x is taken, below x is taken, first P1 will run, then P2 will run. In first case, when P1 runs, the value x is taken, 10 is taken, and it reaches the value, here it reaches the value 10, and its increment to 1. Increment means 10 plus 1, it becomes 11, and the value is write. W means write x, R means read x. Write x means the value is executed and it's printed 11 here, because after 10 plus 1 11, and value is write means it executed and it comes out from the program and it executes, it's printed 11. Now when P2 will get chance, what is the value of x now? Value of x becomes 11. So x now becomes 11. And so 11 plus 1, it becomes 12. After writing the value means it will printed here 12. This is the first case scenario. Now what will see in second case scenario? In second case scenario, see, P1 comes first. Now initially the value is again 10. Initially the value is again 10. See, P1 comes here and it reaches the value at 10. Now P2 context switches P1. See, context switches P1 means here context switch P1. Here context switch P1 means, see, context switch means P2 stops P1 before going to critical section. Before executing, P2 stops P1. Context, the meaning of context switch means P2 is stopping P1. Now P2 will get the chance. And it will come again. And it will execute from the beginning and it will read the value 10. See, P1 read and P1 stops here and P1 read the value 10. Now P2 comes and again it reads the value 10 and it goes into critical section, means the executing part, and it in 10 plus 1 it increments to 11 and writes the x. Write x means it printed the number x. P2 now first printed the value x. Now P1 will get the chance. See, now when P1 comes, P1 reads the value 10. Now when P1 comes, the value is 10. Try to understand, the value is 10. Now 10 plus 1, what we get? 11 only we get. Now write x means we printed the value 11 only. Now see, this P1 and P2 having the same value 11. You are understanding, no? See, when P1 read the value 10 and it is context switched by P2 means P2 stops P1 before going to the critical section. Before executing, only P2 stops P1. Then P2 runs and the value of x is 10 only, and it runs and it increment the value to 11 and it printed 11. Now when P1 got chance again, and it reads the value 10. Now it goes into the it reads the value 10 and now it goes into the executing state and it increment the value 10 plus 1 11 only. So it printed 11 only. So now these two value, now P1 and P2, these two processes having same value. But in the first case, when P1 ran first, we got 11, and when P2 ran first, we got 12. So this means this second case means race condition. Race condition. Now what do you mean by race condition? See, when order of execution can change result is called race condition. What do you mean by order of execution? Order of execution means at the first case P1 runs first and we got the value 11. Then P2 runs first, P2 runs second, then we got the value 12. But in second case, P1 runs for the half part, then it was stopped by P2. Context switch means it was stopped by P2, and P2 again, then P2 runs and we got 11. And when P1 got chance, then also we got 11 only the same result. So when order of execution, this is called order of execution. Order of execution can change the result. It's called race condition. It's called race condition. This is the meaning of race condition. When order of execution change the result, it's called race condition. Now this is another part. See, now understand clearly. See, this is one process given, and now the bracket starts, the second bracket starts, and this is the critical section. Critical section means, see, there are processes from P1, P2, then up to Pn, P100, up to P100 processes are there. So critical section means P1 will come into the critical section. Then after P1 finishes its work, then only P2 will get chance. After P2 finishes its work, then only P3 will get chance. It will not happen like this. It will not happen like this. P1 and P2 will work together. P1 and P2 will work together in critical section. It will not happen like this. After one process finishes its execution, then only next process will get chance in the critical section. This is the meaning of critical section. So means only one process can enter into a critical section, at a time. This is the meaning of critical section. Now, what do we mean by process synchronization? What do you mean by process synchronization? Process synchronization is required to avoid race condition. Process synchronization is required to avoid race condition. And we have seen now only what is race condition. Means when order of execution can change the result. When order of execution changes the result and we got the same result, it is the meaning of race condition. So process synchronization means we have to arrange the process like this only, so that race condition should not happen if there are P1 to P2 to there are 10 processes. So we have to arrange like this only. We have to synchronize the process like this only, so that race condition does not happen. It should not arise race condition. We have to synchronize the process like this only. So process synchronization is required to avoid. So we are avoiding this race condition. This is about process synchronization. This is the brief idea about process synchronization. So thank you. Thanks for watching. Thank you.